The topic of this study is saving the Earth with shrimp and crab shell, achieving electricity-free air conditioning with eco-friendly thin films. Chitosan is a non-toxic, biodegradable natural organic material that can be abundantly extracted from waste products such as shrimp shells and crab shells, making it an environmentally friendly material. This component can be easily coated on metals to achieve radiative cooling effects and can be applied to metal pipelines, gas storage tanks, etc., to reduce the temperature inside the cavity. Video segment 1 demonstrates the process of coating chitosan films on stainless steel samples. First, let's introduce the steps for preparing the chitosan solution. The main materials required include acetic acid, deionized water, and chitosan powder. Step 1 involves taking an appropriate amount of chitosan powder and adding it to a beaker, followed by the addition of deionized water. Step 2 is to stir the chitosan solution with a magnetic stirrer while adding an appropriate amount of acetic acid to the solution. Step 3 involves stirring the solution for 24 hours, adding alcohol, and using an ultrasonic shaker to remove bubbles from the solution. At this point, the solution is prepared. Next, we will introduce the steps for chitosan coating, and the objects needed are power supply, glass tank, and the prepared chitosan solution. The sample is a stainless steel substrate that has not yet been coated with chitosan. Next, we will coat the chitosan film on this substrate. The coating steps are as follows. Step 1 is to install the electrode substrate, glass tank, and power supply. Step 2 is to drip the chitosan solution into the glass tank. Step 3 is to turn on the power supply and wait for chitosan deposition. Step 4 is to turn off the power supply, remove the completed deposition sample, and place it horizontally to dry. After drying, a single-sided chitosan-coated stainless steel sample can be obtained. On the left side of the image is the stainless steel sample with a single-sided chitosan coating, and on the right side is a regular stainless steel sample. It can be seen that there are colorful interference patterns on the chitosan-coated area. In video segment 2, temperature performance of stainless steel samples with and without a chitosan coating under the same conditions will be demonstrated through experiments. As shown in the diagram, the stainless steel substrate itself can reflect solar radiation. And after coating with a chitosan film, it can further increase the emissivity from 8 micrometers to 13 micrometers wavelengths. This allows for the direct radiative emission of thermal radiation into outer space, thereby achieving the effect of reducing the temperature inside the lower cavity. This experiment simulates the scenario of chamber heat dissipation, with a heat source inside the chamber and samples placed at the top of the chamber. The experiment compares the heat dissipation capabilities of two samples under the same conditions. On the left side of the video is sample 1, a stainless steel sample with a single-sided chitosan coating, with the coating facing outward. On the right side is sample 2, a regular stainless steel sample. The chamber's structure is as shown in the diagram, with the chamber made of polystyrene. There is a heating plate at the bottom of the chamber, connected to a power supply for heating. There are 4 openings at the top of the chamber, with each opening containing a sample. The red dots in the diagram represent temperature measurement points, located at the heating plate and the chamber air. The experiment will simultaneously record temperature and solar irradiance and compare the experimental results of the two samples to confirm the effectiveness of chitosan radiative cooling. The red dots in the video represent temperature, with a total of 5 measurement points, including the heating plate and chamber air temperatures for both types of samples, as well as ambient temperature. The blue dot represents solar irradiance. This video is a time-lapse recording of the experiment, with the top right showing the hourly changes in temperature and irradiance for each point. It can be observed that regardless of time and location, the temperature of sample 1 is consistently lower than that of sample 2. The graph in the video shows the temperature changes over time for both types of samples, with time on the horizontal axis and temperature and irradiance on the vertical axis. The pink shaded area represents solar irradiance, and the dashed pink line represents ambient temperature. Sample 1 represents the stainless steel sample with a single-sided chitosan coating, while sample 2 represents the regular stainless steel sample. From the graphs, it can be seen that when the irradiance is high, the heating plate temperature and chamber air temperature of sample 1 are lower than those of sample 2. This means that coating stainless steel with chitosan effectively enhances heat dissipation. When comparing the heating plate temperature, sample 1 can reduce its temperature by up to 7.1 degrees Celsius compared to sample 2. And the daily average temperature of sample 1's heating plate is 2.8 degrees Celsius lower than that of sample 2. When comparing the chamber air temperature, sample 1 can reduce its temperature by up to 4.1 degrees Celsius compared to sample 2. And the daily average temperature of sample 1's chamber air is 1.6 degrees Celsius lower than that of sample 2.